Welcome to ClickMyProject.com. Title is the noun of the transfer error in the speech recognition closing the valence gap. This is our abstract. Transfer-based architecture have recently advanced and showed promise in a number of machine learning applications. Speech emotion recognition has been a successful use of these systems in the audio domain. Nevertheless, the impact of pre-training data and model size on downstream performance has not been accessed in previous studies, and generalization and robustness and fairness and efficiency have received scant consideration. This contribution does a comprehensive examination of these aspects on many predefined versions. We also examine cross-corpus generalization using the system. This project is implemented for finding the emotion classification using the voice dataset in the .wav file extension and pre-process the sound waves by the data augmentation, noise removal, and spectrum conversion. Extract the features according to the classes like a happy and sad and so on. Data splitting with the ratio of 8:2. Apply the classification algorithms like CNN. Prediction is done for the algorithms and get the output of each of these classes. Finally, get the performance analysis for the deep learning model. This is our objective, sir. To improvise the accuracy with the comparison. To employ the small website for the detection of the classes of the emotion using the WAV file extension. Enhance the performance analysis. This is a flow diagram. We have used the test data set here. Here is the .wav file extension. We have to extract the data and pre-processing it by the sampling, buffering, and framing. Extract the features according to which classes and apply the DL algorithms like CNN and resizing it and compiling it, model fitting, and then finally known as the prediction. Performance analysis, accuracy, and then loss, F1 score, and precision. This is a system architecture. We have the data set in the data set for the .wav files and pre-process it and split the data into train and test in the ratio 8:2 and extract the features. Classification, apply the classification using the DL, that is the CNN. Prediction, performance analysis in this accuracy, loss, validation accuracy, and validation loss. Case diagram. This is a user case diagram. From the user point, we have the performance for the system. First one is the data selection, and then pre-processing, splitting, extraction, classification, performance analysis. This is the diagram. From the start, then load data set, select the data, pre-process the data, and split the data, and extract the features and classification, performance analysis. This is a sequence diagram. We have the 4 sequences: starting, pre-processing, classification, performance analysis. Select data from loading. After selecting, we have to pre-process it. Split the pre-process the data into train and test. Apply the CNN algorithms, and then finally predict the performance analysis. After executing our code, we have the data set like this. This is our sample data set, and we have to convert into the CSV file. This is a CSV file output, and we have the emotions such as 7 type of emotions with the 400 each files, and then this is a sample emotion files wave plot. This is a spectrogram of that wave plot, and then this is the sample happy emotions, and then this is a spectrogram, and this is a neutral, means normal emotion with the spectrum, and then this is a sad emotions, and this is our model. Here we use the sequential model with the tens layer as the 7 output. We have to calculate the 7 out, and then this is a train and test data size, and in our epochs will run. We have the 20 epochs. The 20 epochs here. After here is it represents the loss and accuracy, and then validation loss and validation accuracy. Our train accuracy is nearby 99.58 and tested accuracy is nearby 99.28. This is a sample of sad emotions, and this is what we have to extract the random emotions, and this is the our model. After the model prediction, we have to consider the 7 emotions. Here we have the predictions. Here right prediction, training and testing. It predict